Hello, welcome to the video notes for Module 2.3. You will need a sheet of paper for today and something to write with in your textbook. Module 2.3 is about rotations. And rotations are another form of transformation, much like the reflections and the translations that we did last week. Rotations are a spin. Let's write that down. Rotations, spin a figure. So if you'll remember from last week, a reflection flipped a figure over a certain line of reflection. A translation was a slide of a figure in a coordinate plane. And so now we have the rotations, which are just a spin. And so kind of to illustrate what that looks like, I have couple little plates here, two of them, they're clear. On the back one, have a grid drawn, and on the top one, I have these arrows just to help me line things up. So let's say that I just drew some kind of figure. I'm not even going to make it like a geometric shape. All right, we draw that in quadrant 1. If I want to rotate this figure 90 degrees counterclockwise, counterclockwise means backwards from the way a clock goes, then that would look like moving this axis 90 degrees this way. This is one way that you can kind of help yourself visualize what's going on in a rotation, which is the entire purpose of this demonstration. So your rotation would end up something like that if you rotated it 90 degrees. Remember, it started over here and it moved this way. You'll notice that it's still the same shape, it's still the same size, but the direction that's facing up is no longer the same. It has turned sideways. If I were to rotate it 90 more degrees for a total of 180, I would move, these two should line up, I would move it all the way around. And it would basically be the upside down version of where it started, except instead of being in this quadrant, it's now down here. So it has spun all the way around. 270 degrees of rotation would be like that. And then 360 degrees, as you'll notice, puts our little smiley face right back where it started. The thing to remember about degrees of rotation, now that you have something in your mind to picture when we talk about rotations, one of the things is that the default direction, or the direction that is understood, the default direction is counterclockwise. Counterclockwise is going to spin backwards from the way a clock would go. It spins to the left. If your parents or grandparents or some adult in your life has taught you, righty-tighty, lefty-loosey to unscrew things or to like screw caps down, this is lefty-loosey, right? So counterclockwise. And so if you don't have any kind of direction given, you assume that you're spinning counterclockwise. That's why when I said, let's rotate this 90 degrees, I turned it 90 degrees this way. Technically speaking, I could also have gone 90 degrees clockwise, and that would look like this, but because my default direction is counterclockwise, I spun it to the left. That's the direction that counterclockwise spins. So you have each axis on a grid that's 90 degrees away from each other. That's another kind of piece of background knowledge that we need. So each end of each axis on a coordinate plane is 90 degrees away from each other. Just going to write each other. Unlike a translation, which just slides things in a straight line, and unlike a rotation, which flips things in a straight line, a rotation moves in an arc, moves in a circle or a piece of a circle. And so knowing how much spin or rotation is between these two axes, here and here, or here and here, or anywhere all the way around. Again, can just help us get a better mental image of where our rotations are supposed to end up. Now, typically speaking, you're only going to have about 3 to 4 different degrees of rotation. And the way that we kind of remember this is just every time I do a rotation, I write down all of the rules because I have this little memory thing that I've used to help me learn what all of them are. So we're going to put a label up here, rules for rotating. And you might remember that rules look like X's and Y's. They look like ordered pairs. And it's just a rule that tells us how to manipulate the X and Y's of our original point so that we don't have to draw out or sketch out all of the steps. So the rules for rotating, they go like this. You write down YX, XY, YX, negative first, negative both, negative last. Then we make those points. And then we number our degrees. On the left, 90, 180, 270, going down. On the right, 90, 180, 270, going up. The left side spins left, the right side spins right. And these are all the rules that you will need. Now, I said that there would be 3 or 4. The third one I don't really include in my list. We're going to put this kind of off to the side. 360 degrees, that's a full circle. So 360 degrees returns a point to its starting place. So I don't really write down that rule because 360 degrees just puts it right back where it came from. So I don't feel like there's a need for that rule. So one more time to go through the rules for rotating, because I mean, this is pretty much the entirety of what you need to do rotations. We say YX, XY, YX. Notice how they're stacked up and lined up like that. YX, XY, YX. Negative first, negative both, negative last. 90, 180, 270, 90, 180, 270. Left side goes down, right side goes up, left side spins left, right side spins right. Every day that you're in class, that you're doing rotations, or every day that you're at home and doing rotations, you need to write this down for every assignment that you do that uses rotations. And you need to think it through every time. Don't just copy it blindly. Make sure that you're working to memorize this pattern. YX, XY, YX, negative first, negative both, negative last. 90, 180, 270. 90, 180, 270. Left side spins left, right side spins right. The more you do it, the easier it will get to remember. And that's pretty much all you need for the vast majority of the rotations that you do. So if you know that your direction that's default is counterclockwise, here's counterclockwise, and you'll be able to just look up the rule every time. If it says that you're spinning clockwise instead in your instructions, then you'll just use this list instead. You'll notice that 270 degrees counterclockwise is the same as 90 degrees clockwise. That's what I illustrated a second ago. If I spin this 90 degrees counterclockwise, it goes there. If I spin it from the starting place 270 degrees the other direction, that's 90. There's 180. And there's 270. And it does. You can see that it ends up exactly in the same place. So that's why we don't necessarily have to memorize a whole bunch of different rules. We can just memorize this one setup and look it up from our own little chart that we have made. So let's go do some examples in the book. On page 90, you'll see the same chart, but you'll notice they just have counterclockwise, counterclockwise, Oh, and 180 degrees is the same from either direction. It's halfway around a circle. So if you go halfway around the circle, you can go halfway from one direction or halfway from the other direction, and you're still going to wind up halfway across the circle from where you started. So that's why 180 degrees doesn't need a clockwise or a counterclockwise behind it. Same thing for 360. If you go all the way around, well, you've gone all the way around. It didn't matter which direction you took. It only matters where you end up for what we're doing. So for this information, this is the same thing that we have written down on our notes page. So I'm going to use my notes page instead. And we're just going to check what they've done down here. They had quadrilateral ABCD. They wanted it 270 degrees. Because there is no direction given for 270 degrees, we're going to assume that it is counterclockwise because that's what we're supposed to assume. So 270 degrees counterclockwise, the rule should be y comma negative x. So we look down here and that's exactly what they have. So if you turn an xy into a y negative x, what that means is you're going to switch the order. So instead of x's in the front, the x's are in the back. Instead of y's in the front, the y's are in the back. And this negative x means that you're going to change the sign of the original x coordinate. So let's look at some examples. A was at 0, 2. We're going to switch the order to 0. And then this old front number, it needs to be negative. Well, negative 0 is not really a thing, so we just leave it as 0. But you can see how that works down here. 1, 4, we switched the order, became 4, 1. And this old front number, or the new back number, has the opposite sign. 4, 2 became 2, negative 4. We switched the order and we changed the number in the back, or changed the sign in the back. And then 3, 1 became 1, negative 3. We switched the order and we changed the sign in the back. And the reason we did that is because we were supposed to be rotating 270 degrees counterclockwise. And the rule for that is y comma negative x. Let's do an example together. On page 91, we're going to be rotating triangle KLM 180 degrees. Well, on our chart, 180 degrees, no matter which direction it goes, would be negative x comma negative y. So negative x comma negative y means that we leave our numbers in the same order, but we switch the signs on both. So 2, negative 1 would become negative 2, positive 1. 4, negative 1 would become negative 4, positive 1. And 1, negative 4 is now negative 1 and positive 4. All we did was to change the signs. Everywhere we had a point, we changed the signs because that's what our rule said to do. So when we graph that, we need to kind of be able to envision where this is supposed to go. So if I start with the triangle down here, I need to go 2 quadrants away. So here's 1 quadrant, here's 2 quadrants. So our new triangle is going to be somewhere over here. And because it is spinning, and it's spinning, since it didn't say, we're going to assume it is spinning counterclockwise. What it's going to look like is that this KL line is going to be, it's going to travel first, right? So it's going to go farther. This little point M out here, it's going to be in the back. So as this spins around, M is going to rotate up to the top. So let's see if that's what happens when we plot all of these points. So K prime is at negative 2, positive 1. L prime is at negative 4, positive 1. And M prime is at negative 1, positive 4. So when we connect, that is what happened. KL, the line, is at the bottom. M prime is at the top because as it spins, the direction changes. And that's a rotation of 180 degrees. On the next page, we have a rotation of 90 degrees. So on this rotation of 90 degrees, we're going to do yx, xy, yx, negative first, negative both, negative last. And then we go 90, 180, and 270. 90, 180, 270. Left side spins left, right side spins right. So for 90 degrees, we're going to assume counterclockwise. We're going to use this line of our chart. So our rule is going to be negative y comma x. This means that we take the x comma y ordered pair and we switch the numbers and change the sign on the new front number. So if my points are P, and then I'm going to put P prime down here, Q, Q prime, and R prime. Just going to set it all up so that I can work with my numbers only. The original coordinates for P are 2, 1. The original coordinates for Q are 4, 1. And the original coordinates for R are 4, -3. Now we're ready to change our points. We're going to switch the order and change the sign on the new front number. So I'm going to switch the order. 1, 2 is the switched version for P prime. And then I'm going to change the sign on the new front number. So +1 turns into -1. On Q prime, I'm going to take Q, which was at 4, 1, and I'm going to swap the order into 1, 4. Then I'm going to change the sign on my new front number. So for 4, -3, we switch the order, and then once again, we change the sign on the new front number. So now we have our coordinates for P prime, Q prime, and R prime. So we can plot those to view our rotation. If I'm rotating at 90 degrees, and again, it's going to go counterclockwise because a different direction is not specified, I can imagine that this triangle is going to go up one axis because each axis is 90 degrees of rotation away from the next or the previous. So I'm going to expect PQ to kind of be hanging out over here in quadrant 2, and I'm going to expect R to be somewhere up here toward the top of quadrant 1. Let's see if that's what happens. P prime is at -1, 2. Q prime is at -1, 4. R prime is at 3, 4. So you can see that's exactly what happened. It spun 90 degrees around. This is P prime, Q prime, R prime. There we go. So line PQ, where it was horizontal, it's now vertical because that's a 90-degree change. The next one rotates 270 degrees. Once again, there's no direction specified, so we're going to assume it goes counterclockwise. That's the correct assumption to make. And 270 degrees counterclockwise is the last row of our pattern. So y, -x. So y, -x is what we're going to do to all of these points. I organized this one with the 2 P's together and 2 Q's together and the 2 R's together, just to show you that you can organize them anyway. I'm going to put D, E, F, and G together in this list. G is at -3, -3. F is at -1, -4. E is at -1, -1. And D is at -3, +1. So that's going to turn into D prime and E prime and F prime and G prime by rotating all of these points according to the rule y, -x. So y, -x means that we're going to switch the order, right? Because it used to be x, y. That's how an ordered pair is normally set up. That's what we have over here. We have x, y, and we need to end up with y, -x. So we're going to take the y which is 1, and we're going to move it to the front. We're going to take the x, which is -3. We're going to move it to the back and change its sign. So 1, 3 is where d prime goes. For e prime, we switch the order, -1, -1, and we change the sign on the new back number. For f prime, again, switch the order, change the sign on the new back number. G, we switch the order, we change the sign on the new back number. And we just repeat this rule for 270 degrees of rotation for every point that we have. So this is our set of coordinates for our rotated figure. Let's imagine where 270 degrees is supposed to go. If we are spinning 270 degrees counterclockwise, D is kind of close to this axis over here. So 90 degrees would put D kind of down here. 180 degrees would put it over here. 270 would put it somewhere up here. This is point D. And point D is going to be the tail end of this figure. So if D is over here, I'm going to expect E, F, and G to be out in front of it. So remember, this is traveling in a circle. So it might actually be where D is kind of up and then E, F, and G are kind of angled down. Let's look and see if this general area is where we end up. D prime is at 1, 3. E prime is at -1, 1. F prime is at -4, 1. And G prime is at -3, 3. So then we have D, E, F, G prime. And you can see that this is almost all the way around the circle. Okay? It would have been the same effect as if we had rotated it backwards or clockwise 90 degrees. Because it's just one axis away if we spin it the other direction. And again, that's because all of this is moving your figure in a circular pattern. So I can go 3/4 of the way around the circle in one direction, or I could just go 1/4 of the way around the circle in the other direction. One of the things that sometimes gets used is instead of thinking about it all with the page upright, you can turn the page kind of sideways. So you can turn your whole paper, much like we were doing here. If I wanted to rotate this 90 degrees, I could look up these coordinates and I can do how we've been doing in our book. Or I could just kind of imagine my whole paper turned to the side, right? That would also rotate it 90 degrees. Okay, so other things that were not necessarily covered in the textbook include rotating around a point that's not 0, 0. So we're going to put a big star on our paper, and we're going to call this rotations centered at a point other than 0, 0. And then we're also going to call this the origin. 0, 0 is the origin, and most of our translations will be centered around the origin. That's the same kind of translation that we've done over on previous pages. Our center of rotation, the part that stayed the same, was right here. And so we were able to just spin this around the origin. Same thing here. When I spin this page or this plate, the part that kind of stays put, that doesn't move around, is right here in the center. I can spin without getting my finger off of the origin in a perfect world. So that point stays still and everything else spins around it. Sometimes you need to have rotations that are centered elsewhere. And so really what I find to be the best way to accomplish those rotations without making it overly complicated is to pretend that that point where the rotation is centered, pretend that it is the origin and give yourself all new numbers. So step 1, temporarily move the origin. The way you're going to do that is you're going to draw or imagine new X and Y axes that meet at the point where the rotation is centered. So draw new X and Y axes that meet at the center of rotation. So let's see what that would look like. In our book on page 95, I'm going to use some of these examples. Let's say that this is going to be centered, we're going to do 270 degrees, centered at -2, comma, that looks like -0.2, centered at -2, comma, 2. So if I want my rotation to be centered at -2, 2, I'm going to put -2, 2 as my new temporary 0, 0. So I'm going to have like an imaginary y-axis and an imaginary x-axis. And then after I have done that, step 2, you're going to give yourself new coordinates. Get new temporary coordinates for all of the points, or for each point. So what would that look like? I've got my new origin. I know I have the point A and the point B and the point C. And if this were 0, 0, like I'm kind of imagining that it is, A would be at 0, 1. B would be at 0, -2. And C would be at -2, 0. That is what getting new coordinates would look like. After you've done that, you have set yourself up for using our regular rotation rules. So use the rotation rules, which again, just because the more we repeat it, the easier it is to remember. Yx, xy, yx, negative first, negative both, negative last. 90, 180, 270 on the left. 90, 180, 270 up on the right. Left side spins left, right side spins right. So these are the same exact rules that we wrote earlier and that we've been using, but now we can use them to find this new point, even when the rotation is not centered at 0, 0, because we've recalculated and made the center of rotation our new 0, 0. So if I am rotating 270 degrees, that's going to be y, -x. So y, -x is my rule, and that's what I'm going to put over here. So for A prime and B prime and C prime, I want to do y, -x. So that says switch the order, and the new back number becomes negative. So from 0, 1, I get 1, 0. -0 is not a thing, so we're not going to put -0. 0, -2 becomes -2, 0. I would switch the sign on this, but 0 has no sign. Again, -0 is not a thing, so we're not going to put that. And for C prime, -2, 0 becomes 0, +2. We did get to change a sign this time. So I switched the order, and I made the new back number the opposite sign. After you've done that, last step, plot your coordinates. And look up their actual coordinates. So I'm going to plot. Let me get a different color so you can see where I'm plotting. We're going to plot A prime at 1, 0 on our temporary axis. So 1, 0 would be A prime. B prime is at -2, 0. So -2, 0 is going to be B prime on our temporary axis. And then on our temporary axis, 0, 2 is going to be C prime. So you can see we started with our figure just like that. And because we spun 270 degrees, it's almost all the way back where it came from. It actually overlaps its own pre-image. So now all we need to do is we need to look up the actual coordinates for A prime, B prime, and C prime. So A prime really on the original coordinates is at -1, 2. B prime really on the original coordinates where 0, 0 is right here, the numbers that are on the graph, B prime is really at -4, 2. C prime is really at -2, 4. And that's how you perform a rotation around some point other than 0, 0. Let's do another example on number 6. So on number 6, we're going to rotate it. It says 90 degrees. I'm going to throw a couple of extra details in there to make this a more appropriate example for what we want to do. So I want to rotate this 90 degrees clockwise about point R. Now, the reason I wanted to use this example is because of this word about. About just means around. We're going to rotate around point R. But I wanted you to have seen this wording in case it comes up later on. So about just means that's where you're spinning it. Just like when we had a point that was on a line of reflection, that point didn't move. When you have a point on your figure and that is the center of rotation, that point is not going to move either. So I want you to notice that as we go about our regular set of steps over here. So once again, the first thing that we do, I'm going to use some lighter colors so it perhaps doesn't muddle up our image too much. So the first thing we're going to do is we're going to make a new set of X and Y axes, and it's going to be 0, 0'd or centered at our center of rotation. So it's going to be centered at R. So I'm going to draw my Y axis, going to draw my X axis, and remember these are just temporary X and Y axes that we are imagining for our own purposes. Then I'm going to get new coordinates. So R is at 0, 0 because its rotation, our rotation is spinning around R. S is at our temporary -1, -1, 2, 3, 4, 5. So -1, -5 on our temporary axes. And T is at 1, -5 on that temporary set of axes. Then we're going to think about our pattern. Okay, so our pattern for rotation is YX, XY, YX, negative first, negative both, negative last. And then we have 90, 180, and 270 going down, 90, 180, 270 going up. The left side spins left, the right side spins right. And you wouldn't write this every time. I'm just repeating it as many times as I can just to give you some extra experience hearing it, hoping that it sticks. So if we're going 90 degrees clockwise, this is the clockwise direction. 90 is way down here. So we're doing y comma negative x. So y comma negative x is the rule. And we're going to switch the order and make the back number negative. So r prime is going to be at 0, 0. When you switch the order, you still get 0, 0. When you change the sign, you end up with still 0 because negative 0 is not a thing. On s prime, we switch our order, negative 5, comma, negative 1, and then we change the sign on the back number. So now it's positive 1. On t prime, switch our order, negative 5, comma, 1, and we change our sign. So positive 1 becomes negative 1. So these are our coordinates that we plot on our temporary axis. So our temporary axis is the pink ones, right? So r prime is going right there. And then s prime is at negative 5, comma, 1. So negative 1, 2, 3, 4, 5, 1. That is s prime. T prime is at negative 5, negative 1. So there's negative 1, 2, 3, 4, 5, negative 1, T prime. We can connect those so that we can just envision what we have rotated. And if you're considering these pink lines to be our axes, this makes perfect sense. We have rotated 90 degrees, which is one axis away. And in the clockwise direction, that spins us up like this, up to the left. So if the original axis, remember our imaginary one, cut our triangle in half, it makes so much sense that our new axis in our new location would also cut this triangle exactly in half. So our final step is to get our actual coordinates. Remember, we've made up these coordinates and just kind of relocated the center of our graph so that we don't have to memorize new rules. So what we need to do is remember to go back and find s prime, t prime, and r prime on the actual graph. So on the actual graph, r is still at 3, 1. And s is at negative 2, 2. And t is at negative 2, 0. And that is how you will rotate around a point that is not 0, 0.